The first part of section 10, terms and parts of circles today. So first of all, what is the definition of a circle? It is actually defined as the set of all points in a plane that are equidistant. A circle is defined as all of the points that would be equidistant from the center of that circle. So here I'm going to mark where I believe the center is, and I'll call it C for center. So that point, if you think about it, every point on a circle is the same distance away from that center C. Picture like if you're putting your dog on a leash outside, and let's say you put a little stake in the ground and then you let him go on the end of his leash and he walks all the way around it, he would form a circle. Okay, it's the set of points that are all equidistant from that center. And we name a circle by the center. To put a symbol for a circle, we just do a circle with its center, and this would be circle C. It is named by its center. Okay, so use that circle symbol, dot in the middle, to be the center, and make sure you give the point for the center there. One of the most important segments that you should know for a circle is the radius. Now, a radius is a segment that goes from the center to a point on the circle. Every radius that I would draw in this circle would be the same length, would be congruent. You should also know what a chord is. A chord is a segment in a circle, but the endpoints are both on the circle. So I would draw a segment where both endpoints are on the outside of that circle. That would be a chord, this green segment here. And then a diameter. Now, a diameter is actually a chord, but it's a special chord because it has to pass through the center of that circle. This then would be a diameter. Because it's a chord, it has both of its segments, both of its endpoints on that circle, and it does pass through the center. Keep in mind that a diameter is made up of two radii together. Okay, it's a chord that passes through the center, and every diameter that I would happen to draw in this circle would also be the same length. So, definition of circle, and make sure you know the parts radius, chord, and diameter, and we have a few more parts to talk about. A secant. A secant is a line that intersects a circle in 2 points. So it's a line that goes through a circle and hits at 2 different places. This would be a secant. And maybe I'll label this as SC for secant. And if I would talk about the secant, I would put my line over the top. And there's something to be said about being careful with that line over the top, because let's say I talked about SC as a segment instead. Well, that would not be a secant because I don't have the line over the top. If you think back, in this example here, we talked about this as a chord, right? And maybe I'll do H and D. Now this is a chord, but it is a segment. The endpoints are on the circle. So if I go back here, if I'm talking about line segment SC, I'm only talking about the portion, the segment actually inside the circle in that case. I would be talking about a chord. So be real careful that when you're talking about a secant, it is the actual line going all the way through. If you're only talking about the segment portion, and you only have the segment on the top, you're talking about that chord. And then tangent, something that's going to come up a lot with circles. A tangent can be a line, array, or a segment, but the whole thing is that a tangent can only intersect that circle at one point, exactly one point, even if it was extended, because it says it could be a line, array, or a segment, but it can only touch at one point, and that's the point of tangency. So I'll actually use my line tool there so that it looks like, yes, I'm only hitting at that one point. Actually, I'm going to adjust this a tiny bit so it doesn't look perfect. There we go. But it can only intersect at that one point, and I'll label that as T. Now this point T is my point of tangency. It's the point where that tangent line intersects the circle, just at that one spot. Now this could be just a segment, this could be a line, this could be a ray and only go from here outward as long as it only intersects at one point. I'll do P and T, so line PT in this case is a tangent. By the way, if you do something like this, that's not a tangent. Even though it looks like it only hits at one point, you have to imagine, what if I extended this? Well, now you're going into the interior of the circle and you will hit a second time. So this would not be considered a tangent. A tangent can only hit at one point even if you extend it or imagine it continuing through that circle. Okay, so be careful with that. A tangent can only touch it at one point. Again, be careful with the distinguish distinguishment between a secant and a chord. So let's practice using these terms and give the term that best describes each of these. What would you call line segment DC? Well, D is on the circle, C is the center of the circle. If you go from the center to a point outside, that is a what? Should be thinking radius. What is line segment BD? Line segment, so I'm talking about only the segment from B to D. These are two random points on the circle. I'm not going through the center. It is a segment. You should be thinking that this is a chord. What is line segment DE? Line segment DE. Here's D. Here's E. Both endpoints of the segment are on the circle. Notice we are passing through the center. What do you call that? Should be saying diameter. What about line? And noticing the arrows, line AE. Alright, A is here, E is here. I'm talking about this entire line. Notice it only touches the point, or excuse me, only touches the circle at one point, at point E. This is a tangent line. A tangent line, or a tangent, is only touching a circle at one point. E would be the point of tangency in this case. And what would you call line AD? I'm talking about the line A to D. This line goes through the circle and hits at 2 points, B and D. What is that called? That is a secant, if it's a line that goes through a circle and intersects at 2 points. Okay. Little discovery questions for you. What is the longest chord in a circle? Remember that a chord has its endpoints on that circle? The longest chord in a circle is actually the diameter. It's a chord that goes through the center of the circle. I'm going to go back here. Yes, this is a chord, and it goes through the center. Now, the chord we were actually talking about before was BD. This is definitely shorter than this, and the further you get away from the center, the shorter a chord will become. The longest chord then would be a diameter going through the center. That's the longest chord you can come up with. And then talking about the relationship between radius and diameter, they can also both refer to lengths. They don't just have to be talking about the segments, but you talk about the length of the radius or the length of the diameter. And my question is, how do they compare? How does the length of the radius compare to the diameter? Well, think about every diameter. Isn't this diameter made up of 2 radii? I mean, DC was a radius, right? That was how much of the entire diameter. Well, DC is a radius, and so is EC. You have 2 radii making up 1 diameter. So a radius is what compared to a diameter? Well, radius is half of a diameter, right? Because the diameter was the entire ways across. Radius is only from the center outside. And a diameter is what compared to a radius? Isn't the diameter going to be twice the radius or 2 times the length of the radius? Because there are 2 radii that make up 1 diameter. Okay, so either of these, just be familiar with the change between radius and diameter. Oh, we also talk about coplanar circles and the intersections that can be possible between 2 circles. The first case that is possible is, let's say you have 2 circles and they cross at 2 points. They have 2 points of intersection like these. And that would be possible with different size circles and a lot of different visuals, but 2 points of intersection is common. There could also be just 1 point of intersection. That happens if one circle's inside the other and they only hit at 1 point. It also happens if the circles are touching at 1 point, being kind of next to each other in this case, and they're called tangent circles. Remember that tangent means you only touch at 1 point, and so these are called tangent circles. These are not, because you have one inside the other, so they're a little bit different. And also, circles might not cross at all. They might have no intersection, as these 2 circles are totally separate. Or one circle's inside another. Now, this is a special type called concentric circles. Concentric circles have a common center, and that is shown right here. Both of these circles are centered at that point, so they are concentric circles. If you think there are some good examples in real life of concentric circles, what about a dartboard? Or the target that you're shooting at when you shoot arrows in gym class? Either of those would deal with concentric circles, right? The circles have the same center. And we also talk about common tangents. Now remember, a tangent can only touch at 1 point. So a tangent only touches a circle at one point. But you can have a common tangent if you have more than one circle and you draw a line or a ray or a segment that is tangent to both of the circles, tangent to two coplanar circles. Oh, by the way, I didn't mention that on the previous slide, but coplanar, remember, means on the same plane or on the same flat surface. But we're going to draw some common tangents, some lines that are tangent to both circles, meaning they only touch at one point on both circles. In this case, we have two circles that intersect at 2 points. Can you picture a line, or maybe more than one line, that would be tangent to both, that touches both circles at just 1 point? What about a line? I'm a little bit off, so I'm going to go like this and move it over. What about this line right here? Wouldn't you say that that touches both circles at 1 point? Touches this circle at 1 point and this circle at 1 point. This is a common tangent. It is tangent to both circles. And isn't there another common tangent here? What about this common tangent? It's tangent to both circles because it's, I'm sorry, this isn't quite perfect, but it's only touching at 1 point on both circles. We have two common tangents in this case, which is kind of neat. So if circles intersect at 2 points, they have two common tangents. How many common tangents do these circles have? Well, I can do what I kind of just did with these, right? I can do these segments that are sort of to the left and the right. If I can get that to match up, there's one common tangent. Another common tangent would be right here. But there's more. These are external, common external tangents because they're outside both circles, but can you picture? There's actually two more lines that you can draw that would be tangent to both circles. What about going through the middle and hitting both circles in exactly 1 point? Adjusting this just a little bit so it looks really good, but this would be tangent to the small circle, also tangent to the larger. There's a common tangent. And I could do a similar one, but going through this way. I'll adjust that so it looks good. Now I'm tangent to the circle here, tangent to the bigger circle at exactly 1 point. In this case, these are two common internal tangents because they go on the inside, and there are 4 common tangents between two circles that are non-intersecting. Kind of cool. Alright, here we have, oh, these are the tangent circles, remember, because they do touch themselves at 1 point. So actually, there's a cool common tangent that I could do right down the middle. Okay, there's one common tangent. What about this tangent? It hits both circles at 1 point. And what about this tangent hitting both circles at 1 point? I'm going to adjust these a little bit so they look good. But it looks like in this case, I can do 3 common tangents. This line is tangent to both circles. This line tangent to both circles at the same point. And this line tangent to both circles. So 3 common tangents here. And what about on this one when there's a circle inside a circle? I know they're already tangent themselves here, so shouldn't I be able to draw a tangent line right through there? Is there anything else? Well, I can't go in the interior of a circle. Remember, a tangent line can never go inside a circle. So that's the only common tangent I can draw in this case. So talking about circle basics today, and tangent lines and common tangents between circles based on how they intersect.